about the structure of the muscle. And we had taken it and worked our way down from what we would see as the big muscle.
Wait, so is it not playing?
Is that what you're looking for, that red light flashing?
I just don't know if it's playing. I think it is playing. I don't know. Yeah, okay, it's playing.
Okay. Good.
I see the light flashing.
What's the little light from?
Just like with the red light. Does it mean it's recording?
Yeah.
Oh, okay. All right, so we had taken and worked our way from where we're looking at a big muscle all the way down to what I refer to as being the muscle cell, okay? Remember, if I say muscle fiber, I also mean muscle cell. If I say muscle cell, I also mean muscle fiber. So we had worked our way down to that point. And at that point, I mentioned that we're going to have these Z discs, okay? And the Z discs are going to border a sarcomere. Do you guys remember that? And overlapping in that were the thick and thin filaments, the actin and the myosin. So I came across this morning because I was looking at some YouTube videos. You got to hear it, okay? Because it's really kind of interesting. Plus, it actually teaches you some stuff.
Myosin is thick and actin is thin. Myosin is thick and actin is thin. Myosin is thick and actin is thin. Each of these things are called myofilaments. Actin is a thin filament. Myosin is thick. Hope you got that down. Now listen real quick. Myosin has these things called myosin heads. They attach to actin and they pull that thin thread. First, the binding site on actin's gotta be free. Gotta get this thing called tropomyosin that kind of moves, please. You see, tropomyosin has a friend. The name is your troponin. They're attached till the end. Let your troponin bind to calcium, and then you will see tropomyosin will move and set the binding site free. Now that tropomyosin is out of the way, myosin can bond to actin today. Now that they're bound, learn how do they act. How does ATP help to make the muscles contract? Myosin is thick and actin is thin. Each of these things are called myofilaments. Actin is a thin filament, myosin is thick. Sit them down, Brown, and tell them real quick.
First the head is phosphate and ADP. Then you drop the phosphate and what will it be? The power stroke happens and the actin gets pulled. This is part of contraction. Let the story unfold. Along comes a molecule we use for energy. Of course you know I'm talking about ATP. Myosin binds to ATP and let's go with actin. Keep on listening, cause here's the reaction. The ATP breaks into ADP and phosphate. This energy allows the head to cut all the way. If calcium's around, it's time to feel the contract. Actin's binding sites are free, it's time to attach. Myosin is thick and actin is thin. Each of these things are called myofilaments. Actin is a thin filament, myosin is thick. Hope you got that down. Now listen real quick. Myosin is thick and actin is thin. Myosin is thick and actin is thin.
Just thought that was kind of cool, you know, because that's pretty much the point that we're at right now, where we're talking about these myofilaments. And a couple of things that I kind of want to just go back and
You
point
use
out.
muscles every day to do activities. This woman is using muscles to breathe,
We're gonna
circulate
actually
blood,
come back
and move
to
her
that.
pen to take notes.
So we'll come back to that video. So just a couple of things that I want to come back to from the last picture, the last slide that we left off at. And based on what you just heard in the video, did you pick up on anything about, first of all, ions in the video? Did you see anything dealing with ions? You saw calcium. Okay? Now, what about energy? Did you notice anything that they were trying to show you about energy? Well, with our ATP going to ADP plus an inorganic phosphate. Did you pick up on that in the video? Because here's what I'm trying to get you guys to associate with the information about the muscular system. One of the things that I've said, the muscular system is going to affect all other systems of the body. So now I see an ion that's being used, my calcium, but I also see this right here, some ATP. Do you remember the process for cellular respiration? Now, in that process of cellular respiration, we had the little glucoses that could go through the Krebs cycle, get to the electron transport chain, and generate those 32 to 34 ATPs, right? But we also had the process of generating energy by way of anaerobic, okay, where it only took place in the cytoplasm, the glycolysis, okay, splitting of the sugar, where we formed the 2 ATPs and then went to this big, huge molecule called lactic acid that the body had to get rid of, okay? The reason that I'm pointing that out, do you happen to remember if we store ATP? No, we don't. The muscle cell. Now remember, I've had to get you to think outside the box about the shape of the muscle cell. I showed you with like the peeling of a piece of meat, okay? And then one of those long parts would be the muscle cell, that muscle fiber. And it was multinucleated, okay? And when we get down to that point, those myofilaments, the actin and the myosin, were overlapping. Do you remember the banding that I pointed out on the little models? Okay? So our actin and our myosin are overlapping. So what it looks like right here, note we've got the big myosin filament, we've got the tiny actins. If we take that and get a bigger picture, this is our picture that we have now. There's going to be from Z disc to Z disc because this is a sarcomere. So if I had that muscle cell, that muscle fiber laid out, I would see Z disc, Z disc, Z disc, Z disc. Is everybody following me? And that would be sarcomere, 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 sarcomere. Is everybody following me? So in that sarcomere, you find the thick attached to several thin. So if this were the thick filament, okay, at this end, there would be a thin, 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 thin. Does everybody see what I just did? If this were the thick, okay, if this were the thick, okay, thin, 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 thin. And then for this side, because we got two sides, right? Okay, my thick, and then thin, 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 thin. Is everybody following what I just showed? Okay, so on this thick filament, it looks like golf clubs. All right? And they're going to have what's termed the myosin head. So note that on that thick filament, okay, lots of these golf clubs existing. On my thin filament, okay, note the structure of my fin. My fin has a double helix of these globes, okay? These are the actin molecules. On the actin molecule has an active site. Yes, no, maybe. Speak now. The active site is where the myosin head can fit into. So if I have my thin and my thick, and the thick has that golf club head, and if this is one of my actin globes, there's an active site that myosin head can fit into. Does everybody follow me? It was represented on the little video. But, see this other stuff making up the thin filament? The one that looks like a rope is tropomyosin. The one that looks like 3 little pieces to it is the troponin. Yes, no, maybe.
The 3 pieces is the
Troponin. And the one that looks like a rope is the tropomyosin. And it looks like at every bend in that double helix, we have this combination between the two. Does everybody see that? Now, the rope, okay, the tropomyosin, is covering my active sites. There's a reason for that. Okay? But we're not at that point yet. Is everybody following what I just explained about the structure? So if we look at these structures, okay, like I was saying, those actin globes form the double helix. Those globes have an active site. What we find is the tropomyosin and the troponin function to cover up the active sites. Okay? So the tropomyosin looks like a rope. The troponin was the 3 pieces. Okay? At every single bend of the double helix, those 2 meet together. And this is now called the tropomyosin troponin complex.